Mr. Christian.
And we're live. Hello, Mr. David. How are you?
So far, so good. So I think that our last demo was at least was useful for me to understand a little bit about this new feature API about the sharing arrays. So I was wondering, like, what we're going to talk about today.
So, my idea for this stream was to view some flags so we can create some neural networks. And then, uh, I don't know, maybe at the end of this stream or the next stream, we can do like a simple data parallel uh, training, mixing, yeah, what we learned today and what we saw last time. So,
Just
that
to
is the
just to
idea.
recap, just to recap. So last time in the last session we saw one of the feature of JAX 0.4, which was this shared array um, with information on how to do how to shard what could possibly be a long a large array. How to replicate? We didn't see how to replicate arrays on that, right? So are we going to look at this today?
Yeah, we got kind of stuck trying to replicate multidimensional data,
Hmm.
but I've since learned how to do it, so that is good. And yeah, we can do that to shard the model and the data. But I think we should first start with Flax because well, maybe yeah, not a lot of people uh, or just so it gets like for those in the future who might not know how to use Flax, just give them like an intro. So uh, this can serve as a little bit of documentation. So yeah, maybe I'll just go through something similar to what we have in Flax. So in Flax we have like a getting started, which we are improving. So I'll do something similar to what is here, which is basically training on the MNIST. Uh,
Perfect.
so so we will do that. I'll do like a simplified version,
Gotcha.
and yeah, let's get onto it. So yeah, just for those who don't know, like Flax is one of the uh, many neural network frameworks in JAX. There are a couple. Flax is, I think it's probably the one that has the most users right now, and the one that is most heavily used within Google, and the one I contribute to. So
Just a big
I'm a,
disclosure.
I'm a little
Big disclosure.
biased. Yeah, just for disclosure.
Just to one sense. So, how are these like this relation with like DeepMind with Haiku? So, what does the role of Flags and Haiku have in the ecosystem?
That is a good question because many people who are trying to decide what to use, they they get a little bit stuck with okay, why are there two if they're both from Google? Um, I think Haiku is mostly used within DeepMind when they're trying to port their TensorFlow code to JAX.
Right.
Haiku tries to be compatible with their previous system, which I forgot the name, but uh, it, it has a certain layer of compatibility. And
You
then
mean Sonnet?
Flags, yeah, Sonnet.
Mm-hmm.
They are compatible with some structures from Sonnet, I believe. That's what I've heard. Uh, Flax is mostly used within Google Research, and the one that I think outside of DeepMind has the most traction. And yeah, there are others that have gone through the years. I think those two are kind of the more stable. Maybe Equinox is catching on. has a different approach. Uh, but
Perfect.
today, yeah, we'll go with Flax. So uh, Flax, for those coming from maybe Keras, is like a functional framework. So uh, you'll see that you can sometimes use this magic decorator to define submodules on the fly, and then just use them. You don't have to set them somewhere. There is a way to set them like as a field and then reuse them. That is possible.
Right.
But the other feature is that since it's functional, the the weights of the model are stored. Maybe maybe I should close this.
Mm-hmm.
The weights of the module. So you define it, and okay, it's a module as maybe you see in PyTorch, but when you're actually going to use it, uh, you have to use a functional API. So there is a method to initialize the weights, and then when you're going to do the forward call using apply, you have to pass the weights.
Perfect. So
So
this I guess is follows since people since it's based in JAX, we need to follow all the random and guidelines to control to be functionally pure and being able to set the values of these parameters, I guess.
yeah, that would be this part, the PRNG.
Mm-hmm.
But the module system itself behaves stateless, so the variables are kept outside. I think that is the biggest difference with what you get from maybe PyTorch and Keras. Uh, there are ways, for example, Equinox, the module is like a PyTree, and also, well, tricks, which don't use it. I created that one, but uh, you can try to make this a little bit more object oriented. Uh, I don't know. Maybe in a future episode we can discuss
Allergy?
the pros and cons of trying to have like an object oriented system, like neural network system. But for now, let's just say that the variables are kept outside, and then you have to pass them, and the, like apply also has other things you can pass here, but among those is just your data, and that will call the method, the call method, and then here when you're inside this, it's behaves a little bit more like a regular neural network module system.
Perfect.
From the outside, it's functionally pure. So that's just kind of the TLDR for those
The,
who
I guess
don't
that
know.
there is a document of getting started that also do like an introduction to JAX. No, it's just wanted to point out that it's like you don't even you can get like a crash course on JAX from the Flax documentation. So I think it will be really cool if we like if someone that is looking at the stream is looking at to learn Flax or JAX, you can start learning Flax and looking at the getting started with a crash course on JAX.
Yeah, maybe we should do like a JAGS 101 in the future.
Yeah, probably.
Uh, like using JAGS more interesting functions. Right now, we're not going to use like BMap, and well, we are going to use JIT, but uh, maybe more of a low level JAGS tutorial would be nice. For now, let's just in the remaining time code like a getting started. Basically, just solve the MNIST and see what that looks like.
Perfect.
I'm gonna cheat a little bit because I don't wanna write everything. So I'm going to cheat especially on this part where we will load the MNIST. So, okay, this is the part I'm gonna cheat.
Ah,
So,
perfect. So it looks like also Flax is compatible with any data loader library. So I guess that you're using TensorFlow datasets. Yeah, perfect.
yeah, since JAX is compatible with NumPy, then like you can basically use any data loader as long as you can return NumPy arrays. So, okay, we will be doing that. Uh, so yeah, uh, let's see. So first, just let's import the data set. Then we're gonna do, yeah, like a couple of things here. Okay, for this tutorial, we should change it a little bit, maybe. So we're loading the MNIST from TensorFlow datasets. Uh, we we are going to repeat, but let's do something like epochs equals 10,
Mm-hmm.
and then put here epochs. Uh, okay. So we just train for 10 epochs. So let's see. Just for sanity, maybe let's get some samples. Uh,
Just in the meanwhile that you put samples, just to show. So with the TF data has a really cool API that allows you to control to indicate epoch end if you need to repeat. Probably the only weird part is shuffle. You define a buffer, and that buffer is supposed to be a little bit more bigger than the data, and then it will do it will random the elements on set. And the prefetch, it just allows you that at the same time that it's reading well, this data set is on memory, but as soon as the data is available, will be it will do some tricks behind the scenes to augment the throughput of data presented to the either to the iterator or the training model. And yeah. Are you're oh, cool that you're using Copilot to do matplotlib. That's really cool. I'm doing this kind of thing also.
I'm not sure it's getting it right. Uh,
Sample.image. Um,
330. What is this? Okay, I think it's just using subplots. Yeah, okay, this is much
okay,
better.
that makes sense.
Uh, okay, yeah. Let's see what we get.
Would you mind closing the terminal side so we can have a more space to the Jupyter notebook?
Sure.
I will refer in the terminal, the terminal, like the down
Oh,
the answer component.
okay, yeah.
But, mm.
Aim show and then CMAP gray. Probably want something like this. Okay, yeah. So, okay, just as a sanity check, this is the data. I mean, uh, so okay, let's get to the interesting part.
Mhm.
Uh, let's create a model. So we're going to import flax.linen, which is kind of the API we currently reframe as NN, similar to what you do in PyTorch. I think this will be refactored in the future, so you import NN from Flax. Currently, you do it like that. So let's define, I don't know, like a classifier. Classifier. Okay.
It
uh,
looks like Copilot already know a little bit of Flax apparently. So
yeah.
we use the compact API and we are defining the models, same as like a PyTorch. Okay, makes sense.
Let's code it by hand
Mm-hmm.
because. Oh, okay. We can code this a couple of ways. So let's say if you want to do something similar to what you do like in PyTorch, uh, you can assign modules in inside setup, which is not really the init, but think about it as like something that can be similar to init. So you can say like, oh, linear. Uh, so our classifier, we're gonna do something super simple. We're just gonna do a linear classifier. So we can define a module here, and then uh, just implement the call. So yeah, we're actually going to do, yeah, first like a normalization, uh, and then probably we can do like a reshape here. Okay, yeah, we're just going to flatten it. Okay, yeah, maybe we do it in two different lines. So we're going to flatten as suggested here.
Perfect.
Um and then we are going to apply the linear, which actually can be our return. So like a very simple model. Maybe let's just assign it and return it. So this is one way which looks a little bit more to how you do it in Keras. Maybe we can put like something like num classes. So modules in Flags are data classes. So you don't define the constructor. You just put like the uh, field annotations up here,
All right.
and then the constructor gets created, and then here we can use it like self dot num classes. So you can do it like this, or you can use the compact API, which has the benefit that we're not using it here, but uh, that you can use just these modules inline. Uh, so you just call it on the fly.
Mm-hmm.
And the compact API has the benefit that since you have your data, you can do shape inference. So if you need to create like a parameter for the neural network, you can look at the shape of the data, and that is what is called shape inference. So that is like a benefit, I guess. So your code is usually very like it can be shorter than in other frameworks because
Will be compact.
yeah, exactly, the code will be compact. It's a very good name. So okay, yeah. Let's Okay, that's kind of our module. Let's split this. So as we said earlier, we have to do well, we have to do like a couple of things. Let's import JAX and JAX.numpy.
Hmm?
Uh, let's create. Okay, maybe I'll do it step by step, just so it's nice. Let's instantiate the module. So So we have our classifier with 10 labels. Um, so okay, this is helping too much. Let me turn off
Turn it off.
Copilot for a bit. Uh, Disable for
No,
Python.
just yeah.
So I coded and it's less magical. Uh, so we have to create some variables. So here is the initialization step. So usually you call module init, and then in init you have to pass it some like a random key. So you know that in JAX state, random state is explicit. So you have to pass like some random state. So you get that from the PRNG key. And let's say you pass like a seed of 0. And then here you pass the arguments that would be passed to the to the forward function, which in this case is call. So maybe uh, we can reuse samples, for example, or we can just create some fake data. So let's say, yeah, let's use samples because it's free. Well, we already have it there.
But one
But
thing is that shouldn't I just pass only one element so they can do shape inference, or should I just give also the data with uh, how does it work with
so you just have to pass it a real sample.
mhm,
Ideally, you use a batch size of 1, so this computes a little bit faster.
okay.
Uh, I think in a future version that we're planning, init will actually not consume any flops. Uh, Currently, it runs
So
and
it
it
runs
returns.
one time, and I guess it traces the complete computation, I guess.
Yeah, and then it actually runs a computation.
Mm,
And during the computation, the weights are created. In the future, I think we'll try to be a little bit more clever, and no computation is run. Just your weights get created uh, with some JAX magic.
mhm,
So that that will be better. But for now, it's better just to pass like a sample of 1, so there is the least computation possible. uh, many people say, yeah, well, also like JIT you're in it, like JAX.JIT. That is something is possible in hopes that this consumes less memory, but that jitting sometimes takes time. So eager actually is sometimes faster. I don't know. I don't know if there is a consensus, but in this case, let's just call regular init.
mhm.
And yeah, if we do that, we should get our. Okay, we actually got an error. Let's see. Uh,
There is a problem with the TPU.
TPU is being used. Okay. We are running this, so the TPU is being used. Um, let's maybe restart. Let's hope the other process got killed. We should have. Maybe let's open the other thing and restart to free the TPU. Uh, okay, let's run this again.
Just in just for viewers, so yeah, we are connected to a machine that has TPU, so that's why we have a TPU backend.
Uh, um,
Perfect. So
are
what
there
is
any questions, by the way?
no, not yet. I'm looking
Okay, Just to see what we did, well, we only have a single like dense module, and these is our variables. So our variables contain it's kind of a dictionary that contains some what we call collections. Here's a parameter collection, and then inside the collections are actually like the dictionary of, well, it's an nested structure that contains, well, the weights in this case for the parameters, but there can be other collections. For example, for the batch statistics for batch norm would be another collection.
If I wanted to know like the complete parameters that are trainable, what how can I ask module to show me the number of parameters that it use?
Uh, okay, that is a good question.
Mm-hmm.
So you can use module that tabulate, and then
Oh, cool.
tabulate. Uh, I think you've seen this, right? Because I coded this.
I knew the developer that made the model tabulate and fighting the rich library, but that's cool. That's
Okay.
that's really cool because you're going to get that tab. So maybe we can show. Perfect.
Okay. Oh yeah, right. We have to print it. So tabulate returns like a string, and you have to print the string. But
That
this is something like a keras like representation of the module, and it also has colors, but they are turned off for Jupyter. Uh, and yeah, well, it's a very simple model, right? It goes from the inputs, just and we get 7,000 parameters to solve the MNIST. Uh, let's continue. So, okay, one thing that you usually do, let's do it here. Params, usually extract the params from the variable. So you do params, you do it like this, and then maybe it's just here have only the params. So um, because we're going to create an object called a state, which will hold the parameters plus other things.
hmm
The, so we will create an object called the train state. Well, that's the name of the class. So from fax dot training dot train state. Uh, let's import. So the train
Christian, would
state.
you mind if we can show if we can hide the menu of the files like just to make
Sure.
the font? Yeah, that's good.
Can also make this bigger. Uh, so this object will hold a couple of things for us, and the idea is that it contains all the state that will be used during training to make things easier. So in this case, we can do something like okay, and we have to do here a couple of things. So other things that we need for training is the optimizer. So we're going to import optax, which is the optimization library. So uh, let's create this train state object, and we will see the API real quick.
hmm
So okay, this is kind of a data class, so we use the create constructor actually, and it has a couple of things. So it wants like an apply function, which is like the forward function or something equivalent. Remember this a little bit like a functional API. So we say apply function, and what are we going to use? Well, we're just going to use the apply function from our module.
The call, right? Or the apply, sorry.
The apply. Well, we saw it in Flax getting started. So we're going to use that. Uh, it also wants the parameters, so we're going to pass the params we created up here. Just these are our parameters. And it also wants an optimizer. So they call it TX actually. I think it's like a convention from Optax that the optimizer is called TX. And we're just going to pass it the good old Adam W with, let's say, 1 e minus 3, something like this. So this will be our training state. And the training state has yeah, a couple of methods that it will set up the optimizer state also. It contains it within. So yeah, it kind of bundles a lot of the state from the model and the optimizer, and it also has a forward function, so it will be really useful.
Cool.
So we
Just
can,
to just to make an emphasis, Optax is outside of Flax, right? Would you have it's outside of the ecosystem of Flax.
sure. JAX is a very, let's say, distributed ecosystem. So Optax, search for Optax JAX. Optax is from DeepMind, and it has an amazing API. I love Optax,
Mhm.
and yeah, this is kind of what you should use. I think it's the de facto optimization library.
And this is an object. The Optax at MW returns an optimize. This return an object that it's optimized, and I guess that it follows an API to update parameters and that kind of thing.
Yeah, the train state will take care of that for us, but it has Optax has its own API.
Oh, okay, good.
Uh,
Mhm.
I don't think we'll review it here, but
For
if you
future
want to
reference.
do like use it raw, you can use the optimizer raw. It's very flexible because it handles any pie tree. So a lot of JAX APIs compose by accepting pie trees, which seem to be like a very good API
Mm.
for a very like universal in a sense. So anyway, yeah, we created a state. We can, if you want, uh, just see what we have here. Uh, so the state is a pie tree, so we can inspect it with tree map, and we get a couple of things. We get the training step, which is kind of a scalar. We get uh, the params, which we had, but we also get uh, the optimizer state, which
Okay.
is well, all the state from Adam, so it contains like a copy of the parameters and then the other variables that are used by Adam, which have the same shape as the parameters. Uh, so okay, it's like a little bit of a more complex structure, but this contains everything we need for training. So the next thing we do is create the training step. Um, I don't know how far we are in, much time we got, but
We
let's
are 28 minutes, so no worries.
okay. So our training step will consist of accepting like a state. Uh, for simplicity, I guess let's let's actually just import the train state object. Import train state, so we can use it as a type. So train state, and we get our batch of data, which we will not type. Uh, so in the train step, we have to basically do one gradient step. That implies, well, calculating the loss and all this kind of stuff. So yeah, let's just get to it.
Mhm.
Need to define like a loss function. So usually you can do something like this, and so the loss function is what you will take the gradients with respect to. So we're gonna take the gradients with respect to the params. And here we're going to do the forward pass. So create the logits. And the logits. So remember, state has our apply function. So this is. I'm just gonna put it so we get some. But I'm gonna revert it real soon. So this is basically our module that apply. So it asks us for our variables. Variables is just a nested dictionary. So we create the dictionary on the fly like this, and we pass our params. So this is our variable structure, and then it asks us for our data. So x, we need to pass the input to the forward function. So we need to define x. Let's just say x. So this batch of data is actually something like from typing import dict. Uh, so this is actually just a kind of a dictionary. This will be a dictionary
String
from a
to jump the array.
string to the array.
Mhm.
Let's use jax.array. So yeah, here we're just gonna say batch, and then I think it's called image. So the the data we have here
Is image. Mhm.
has image and also has label. Uh, so this is how we call the module, but we're not gonna call the module directly. We're going to call the function that we have here, which they're the same. I just wanted to get the type signature because this one has a very generic callable, but they are the same object. So yeah, this is the forward pass. So now how do we calculate the loss? The loss is actually, we can use Optax. Optax has a couple of loss functions. So it has the softmax. It's a really long name, softmax stress entropy with integer labels. This is the one we're interested in, and this one has a, so you can pass the logits as the logits, and then the labels as, so here we grab the batch, and it should be labels or label.
I don't recall. Can you take a look at the yeah,
So our sample, let's quickly print our sample. So it's,
image and go down a little bit.
sorry, a
Label.
label.
What?
So in singular. So here, logits, labels. We pass these two. We get our loss. Actually, we want the mean loss, right? So we put mean here, and we can return our loss. Okay, so this is a loss function. Now, in yeah, this is a part where Jack's tutorial would be useful, but Uh, JAX being functional and very explicit, it's very so there is no dot backwards or something like that. You have to explicitly define a function of the gradient. So usually you write something like the gradient is, and then you use so let's do it by steps. So like the gradient function is a gradient with of the loss function with respect to the parameters. So parameters are in state dot params. So very math like. And then yeah, the actual gradients is just calling the grad function. Oh no, sorry.
Yeah, you wanted to have, yeah. So
Yeah,
grad of the loss function, it will calculate the gradients. It will give you a function that you can actually evaluate, and you can evaluate that function on the point where you want to get the gradients.
exactly.
I don't know
So
if we want to also show like grad and evaluate. Oh no, okay.
um, yeah, we actually should get the value so we can plot. So so this one just returns the gradients. There is another one that's value and grad. So we also get our loss function. Uh, so it returns a function that returns a two element a, a pair. Okay, so it returns the value and the gradients. So basically loss and grads. Kind of the only difference. And the loss. So okay, what will be our training step? Yeah, this we calculated the gradients. Um, so now that we have the gradients, we can update our state, and that implies calling the optimizer, and the optimizer updates its internal state and updates and then you have to apply the gradients processed by the optimizer to the actual params. Luckily, state has an apply gradients function which does that for us. So we just pass grads equals grads and we're done. So
Cool.
it does a couple of stuff. You can do this by hand, but it's convenient. And then we're gonna return a couple of things. First, okay, so we want to create some like logs. So we want to create some logs. So just so our metrics basically. So we can have the loss, right? So that can be our loss, and then we want the accuracy, and then okay, we well there there is a library that could do this for us, but let's let's just calculate it
At hand.
here by hand. So something like basically Jax, sorry, JMP dot argmax of the logits. Ah, we don't have the logits, do we?
No,
Uh,
we'll have to reevaluate. I think that for now, just track the loss on if you want to track, or maybe you can return the loss.
no, I think we should return the logits here. So we can return more stuff here. If we return more stuff here, we have to just say
Extra
uh, has aux. I don't know aux aux
has ox. Mhm.
true, and then we get the tuple here. So it's it's not hard to get the value. Logits. Okay, so okay. So argmax of the logics in axis, the last axis, and we're gonna say when this is equals to the labels.
But does it labels comes with integer labels, right? Ah,
Yeah,
okay, argmax. Yeah, yeah, makes sense.
and then we calculate the mean. So this is kind of the basic definition like of accuracy. So okay, we will return our logs and the state, right? So yeah, it's very simple here. Uh, so one thing that we're going to do is obviously we want this computation to be quick, so we're going to JIT it. So you just decorate it with jax.jit, and this will run fast. And in the future, we can now just JIT to handle parallelism, which will be amazing.
Hmm.
Uh, so so yeah, we have our train step. Uh, let's create like the training loop. uh, so maybe let's create like something like a history to record the metrics. Uh, so we're just going to maybe iterate over our data set.
Oh, we have a question from Eric, and it says that is there a way not to define loss function inside the train step so we don't use batch as a global variable with respect to the loss function?
Uh, there is. Uh, let me just do it, but I'll undo it.
Hmm.
This is usually uh, I don't know the less verbose way, but if you let's say code it here, then maybe you can create like an API like labels, right? So uh, so the thing is that then you would need to pass the additional things that are now not in the scope. So for example, state, you need to pass the state, the labels, and oh, maybe you can just pass the batch like this. Uh, or you can pass the image and then the labels, and and then so this function, okay, it's pure, right? We're not passing anything as a capture, uh, and then you can just pass state and batch. So you can do it like this, but um yeah, if you prefer to have something a little bit more self-contained, you can do it like this, and just do this. If you want to reuse it, right? This is useful if you want to reuse it. Let's say right now, in this example, we don't want to reuse it. So actually, let's use the reusable version. Yes, why not? So uh, maybe just put here a train state. So the important thing is that params has to be the first argument to loss function. That's kind of the only thing. So if you see, this is a little bit redundant because we pass params that and we pass state, but state also contains params. But we have to do this because we have to take the gradients with respect to the first argument. So we have to pass it like separate. That's just take that into account. Uh, we could have also passed like the apply function here, like something like uh, just
Uh, yeah,
you know.
that's the only thing is that when you JIT it and there is an object that is outside of the JIT, is there any constraint? I don't recall.
So we can also do this. uh, and then here just pass the state.apply function.
Mm.
So this is not going to be jitted. The only thing that is going to be traced is the parameters. The rest are passed as is. Like there will be no tracing through these. So you can pass non-JAX objects. The only JAX object will be params, if that makes sense for you. So tracers will only flow through here. That's why you can use captures, which usually you shouldn't. But in this case, it's okay. If I hope that made sense. So yeah, let's suppose we have this kind of API. Uh, so let's continue. So the train state, train DS or DS train. I forgot DS train. Uh, okay, this is the part where Copilot is super useful. Uh, we have to call as numpy iterator. So so yeah, we're just gonna iterate. This already has a number of epochs. We're not going to really do like an evaluation step. So we really don't care where the epochs start. We're just going to train. So it's gonna be like a very minimalistic training loop. And we're just gonna call the train step. And the train step just has the new state. And it has the batch. And it returns the logs and the new state. So this this is what we have here, and actually we're just going to append the logs, and let's revive Copilot for a bit because we're going to do some plotting. So okay, this will be training, and let's just for the future create like some losses, the accuracies.
Yeah.
So Copilot is really good at this. Yeah, whatever. This will just create like a plot. Uh, let's see. No more hints. Okay. Yeah. So what we did here was we just assuming we finished training, we we had this dictionary of logs, and we just get like a list of all the losses and a list of all the accuracies, and we plot them here. We want to be very compact. We can actually just do it here.
Mhm.
Uh, so that is what's going to happen. Hopefully, uh, this will run. I just want to from what? What is auto?
Auto? No.
Never seen auto.
Me neither. So
uh, let's just have something so we can see the training. Uh, so hopefully it's really quick.
you're using the TPUs, right? So there is one TPU that it's going to this thing.
Yeah, sure. Here we can use the total. We don't have total steps. Total steps equals ds train. Yeah, exactly. So okay, yeah, this is much better.
That's
So
cool. Like at like 1,500 iterations per second.
actually, if you run this on CPU, it will be as fast. So
Yeah, maybe I know.
Ah, well, I mean, it's just kind of a linear model. I don't think.
Ah, yeah, yeah, of course, makes
Obviously,
sense.
the TPU is good, but
Yeah, yeah,
it,
makes sense, makes sense. It's a cellular model. It's not using anything fancy behind it.
yeah, well, I mean, it's probably faster doing this in. Uh,
Whoops.
so okay, this doesn't look good.
Mm-mm,
So
not at all.
let's see what is happening. Uh, for losing history, it doesn't seem to be learning. Let's see. We miss anything?
Minus grad, maybe?
No, no, no. That Optax does that for us.
Yeah, state. Maybe
So
she restart the
logs
state, log state.
logs comma state. Just curious as are we doing something funny? The accuracy seems very high.
Well,
Ah, okay, yeah, no, I know what happens. We train many times. This
yeah.
already trained.
Can you restart the init? Can you restart the state?
Yeah, actually, let's do something proper. What we usually do is we create a create state function, and then it takes yeah something like this. Maybe not the learning rate in this case because we're just learning it. Uh, just so we can, so, and then here in this line we have so yeah, JAX Flax convention is create like a train state function, like a create state function. Here, just for visualization, we're going to instantiate one. Uh,
Yeah.
but and also sometimes like even better, you say like variables. You, so maybe you do something more
Yes.
like this,
Hmm.
and then here the parameters are just kind of the variables that params. Something like this. Usually it's more like this, but we were because we were inspecting it and that kind of stuff. Uh, but this is useful because maybe maybe you can restart the state here, so we don't get so if we run it twice, it always restarts. Though we might want if we want to keep training, then maybe take it
Take
out
it. Mm.
or just define it like before as we did previously. But yeah, anyway, okay. Now we should get something that makes more sense. I'm a bit amazed that it takes so much to.
And the loss makes a little bit sense.
Yeah, maybe something we can do that is maybe a good practice is uh, we could do something like jax dot the get device get and the logs. Let's see, does this accept a pie tree, an array, scalar, or nested? Yeah. So we're just gonna pass this to the host, uh, so it doesn't take up memory on our TPU. If that makes sense.
So we reduce the time for iterate. Look.
Yeah, maybe each step will take slightly a little more, although JAX is a sync, so it might do this on the background. Yeah, it might not be that bad.
Mm.
Uh, Oh, even better. I think we can do something even better. I've noticed it's good to put the logs on actually on turn them to numpy arrays. I think it might depend on what you're doing, but I've seen it's better to because if your logs if you are running something big and your logs contain tiny so this is what has happened to me. If your logs if you leave them as JAX arrays and they contain just scalars, even though they're very small, they are on the TPU and they might fragment memory such that you eventually get an out of memory, but not because you don't have memory, but because it's still a bit fragmented. So uh, how I've solved this is just convert the logs to numpy arrays. Maybe we have to import numpy, import numpy, and then p, and then we convert them to arrays. So p that as array. So yeah, it's just kind of a good practice. So the TPU doesn't contain any scalars, which you probably don't want them there. So just convert everything to NumPy. I mean, here we're not affected. This is just kind of something I learned. Maybe just encoded here.
That's one of the things that should be like in a document of JAX engineering. Do not fragment the memory. Especially because TensorFlow also have this kind of thing, right? That
Yeah, I
for
wonder how
avoiding this,
TensorFlow deals with it. This happens when you're actually pushing the TPU like to the limit to have the maximum amount of the biggest model you can, and then when you start pushing it, you find these kind of things. Uh, so now this is fast because previously when we were gonna plot it had to fetch each
hmm,
scalar from the TPU, which was slow. Now it runs really fast because everything is in memory in NumPy on the
we
CPU.
reduce 2 seconds, 0.2
So
seconds.
so yeah, well, I mean, good practices, right? So yeah, yeah, the model train it's obviously noisy uh, because we're not doing any smoothing or doing it like calculating it over like for example flax I mean sorry keras does it but okay yeah this is kind of a very basic training loop. uh,
Christian, we have a question from Samiak that says that what do you think about Equinox? And he prefers set over Flax since the abstraction is simple. So good to know that we have one of the authors in the paper from Equinox in the video.
I'm an author. That's because Patrick was very kind. But I have discussed Equinox, at least some of the fundamentals with Patrick. Equinox, and let's generalize it to PyTree modules. Uh, they are very user friendly in the sense that it's like very easy to get started and it feels very natural. I mean, I coded my own framework like this, and that's why I discuss a lot of things with Patrick. But uh, I think currently there are a couple of challenges of using this type of API regarding. Uh, I mean, it's curious, but the hardest thing to do is something like batch norm. If you look at Equinox batch norm, Patrick has gone to great length doing some experimental stuff to give it support. So stateful operations they are very scary in PyTree modules. Um, I mean that's kind of a TLDR state
Hmm.
in JAX it's hard. In PyTree modules is a little bit harder because like abstractions like Flax and Haiku, they usually provide like a pure API, but beneath there is kind of a like a stateful API, but I mean it's handled by the framework, so JAX doesn't see the statefulness. Uh, if your module is a PyTree, you cannot rely on that. So like there is no background, there is no like trick because it's very simple, but then handling state becomes harder. I do believe, I mean, this is kind of just my prediction for the future. Frameworks like Equinox uh, or maybe Flax 2.0 could be like I guess, the way things could be done in the future if JAX improves its support for a state, and I think Jackson it's going in that direction.
Right.
But for now, uh, yeah, there are limitations to what you can do with like PyTree modules. You can try to overcome the limitations, but then yeah, for simple stuff, I think that is great. But like people who use Flax at Google, they do very complicated stuff, and then like frameworks like Equinox would start breaking. So I think it depends on where you are. Like,
Mhm.
um, yeah. Also, yeah, there are some things that Equinox could add. I don't know. Maybe I'll send a PR to Equinox. Uh,
Sure.
there are some things you can do such that you don't pass things as a capture, and then you updated the state, and then it freezes. Those kind of things are ill-defined in PyTree frameworks. Anyway, that's kind of my opinion. Give me a second.
Yeah, sure. Just to give another opinion is that as usual, most of the most difficult parts in computer science is to manage the state. So you can see that this is leaking also in this kind of sense. So being able to track the state, I think, is one of the most painful parts that you can do when you are like developing a machine learning a neural network framework. So as usual, that's going to be it. I was wondering, Christian, like we are like around the mark of 55 minutes. So I was wondering maybe we can do the if we can do the like a demo of of sharding the MNIST and doing multiple model on this.
Should we try it? Yeah, we're
That was one of the things that I wanted to. I mean, technically we did it before.
yeah. So model parallelism. Do we want to do model parallelism in 5 minutes? Let's save this notebook and create
Copy.
like a copy. So
Mhm.
this is like I guess
Multi data
like
parallelism.
data parallel something I guess.
So you already are using the TPU. So what is the clean way to being able to keep use the TPU?
I just kill the uh, yeah kill the IPython instance, and then yeah, we can just run it. Let's try it, but let's pretend the episode ended. And
Uh,
so
but Christian, you're still using the getting started. So I think that you run the getting started, not the
uh
data problem.
yeah, okay, okay, kill this and then use this one.
No.
Okay.
We're assuming
Uh,
that the episode has ended, but we're going to try to do this is to use the the data, the shared array that we that Christian showcased last episode. So we'll see how it goes.
Yeah, in theory, it should be super simple. Uh,
Famous last words.
but this in theory stuff is, not so okay. Let's import this stuff. Like somewhere here. So we have to. So we're gonna do data parallel training. So we have to define a mesh and some axis. We only need a single axis, and we are just going to do something very similar. So, uh, yeah. Uh, Actually, let's copy this from the JAX docs. Um, to simplify, they had like a shortcut uh, function def like this one.
Mesh sharding. Yeah, you got it.
So let's do this. So the default mesh, let's assume we're just going to use a single mesh because here to be very general. So only mesh, and this will return the shard. Actually, this.
We just rename a function, right?
Yeah, we just no, this doesn't make sense. What I wanted to do was to also do this like I don't know, and then put the data. So like put in mesh, something like this. Uh, so we get the piece spec, and then maybe we have the data here, data, and then so this is a sharding, and then we return jax dot
Device put.
device put the data and the sharding. Very good. So yeah, and we're just gonna put it always in this mesh, but we are going to accept this partition spec. So I think with this we can very easily convert everything. So okay, first thing is that we maybe in our create state we are going to shard it. So so we're going to put in mesh, but we're going to put the state, and then I think is this will say it's replicated everywhere. It's the same as putting like none here. Like if you don't pass anything, it assumes none, and it will replicate everything. Uh, yeah, because this accepts a pi tree. So okay, very simple way to replicate. Let's just see that this works. Our new create state. Okay, we messed up.
Class integer. What?
Okay, maybe let's convert everything to arrays. State equals x dot tree map, and then jmp dot array state, something like this, as array. Okay,
Yep.
so we sharded our data.
So can we
Uh,
take a look if the state, if one of the arrays is actually, can we take a look at the TPU, how the device is, yeah,
params dot, let's see, we have to get what dense zero kernel dot
I don't recall. It's on the text JAX
sharding,
array. Ah, sure.
something like this. Okay, yeah, stuff happened. It's charted. So yeah, can't believe we're doing this like at the end. Maybe next time we can
Yeah,
dig into this. But okay, everything is sharded, and then so that is fully replicated. We just to be clear, replicated the state in all devices, and then here we have to do the same for the batch, but for the batch, we put in mesh, and then we just so we're going to shard the data over the devices. So this time, I don't know if hopefully this might make more sense in the future, but over the first dimension, we're going to, instead of replicating it, we're going to shard it. In the first dimension, we named it data. Uh, Hopefully this makes sense. So we just put the data sharded. Uh, can maybe uh, very quickly do this here for the samples. So like the samples that we had up there, and then like image, and then the sharding. So
looks, hmm,
same, but this time the partition spec
this is data.
has data, which that should mean like address, maybe the labels, label. Uh, what was it called? Addressable shardings. Nah, it's too complicated. But let's assume this works.
It's on the test JAX array. Maybe if you want to take the method out of the other notebook.
Let's assume this works.
Famous
So
words.
previously it took 30 seconds. Hopefully, as we're doing data parallel, it takes less. At this point, I mean, if it works, it's pure magic. But I mean, I've never done this. We're just speculating that it would be this easy, but it's actually slower. So our model is so slow that synchronization
It
is
takes
killing
more of the
us.
time. Yeah. But it works. That's the amazing thing. That it just works.
Yeah, let's see if it trains. And yeah, the thing is that it just works TM, with the caveat, and people on Twitter will fight you that like manual synchronization is more optimal, and it obviously is. But doing data parallel so easily, let's see, how many lines did we modify?
Like the cell to create the mesh and everything, and they are putting the cell on mesh. Like one,
We added two here. Well,
two.
one because of the edge case, but
Mm-hmm.
truly we added one. This has an edge case, and then we added two here. Well, our helper function is obviously doing a couple of stuff, right?
Hmm.
So helper function, but our actual previous code, and it trains. So Yeah, that data parallel training in I think we took what 10 minutes. I don't know.
No, less than that.
Yeah,
But
wow.
can you go a little bit back? Yeah, it trained. So yeah,
Yeah,
that's
this we didn't change anything. This is the magic. This is the magic of the new JAX that array. Previously, this was Pidget. I never used Pidget. It was kind of experimental, so kind of stayed away from it.
I
But
think
now,
that's really cool, and we can end up and eventually in the next stream we'll see, and maybe what we can do is much bigger. I think that here the constraint is that the model is so simple that it's not you don't see any benefits of doing this replication. Um, I think that we could do is what would be like a much bigger data or a much bigger model.
yeah, actually, maybe next stream we can explore like trying to improve this with a better model and that kind of stuff. I don't know, maybe a bigger data set, maybe sci-fi or whatever. Uh, but yeah, yeah, it was amazing. We just had to add so little. Uh, I wasn't sure if it would work,
Yeah, yeah.
honestly. So
I
so
could see it. I could see it. So I think that's it.
there's a question maybe.
Yeah, do you know any good resource about building Flax workflow for research? I find PyTorch Lightning plus CLI using for fast prototyping and keeping track of experiments, and I didn't find any equivalent.
Oh wow. Should I do a couple of how do you call it when you insert your own work into the discussion?
Promotion, endorsement, not well, not paid endorsement.
No, no, there's a word like okay, I'm just
The
gonna I'm just gonna do like insert my own work here. Um, so there are two things. One is elegy, which yeah, I've been working on. A lot of people, David worked on it also. It's more of a it's more of a Keras like API. So I don't know. I should push a next version of this. Uh, yeah, it has its own module system, but which is based on tricks. But you can use Flax. So imagine we use Flax, and then yeah, it has a Keras like API, and you can call fit. It also has like a low level API where you can uh, use something more like what you get in PyTorch Lightning. So 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 you can define your own like just define the loss. But yeah, I was also working on like the next version of this, and I got distracted and I created a
CQ?
another. I created another abstraction which we might do a stream in the future. Uh, this I feel this is more. I mean, I have to put more work into this so I can actually release it. I've never talked about this in public, but I've been using it myself. It's like a functional version of. It's like a functional framework for training, and it's much more low level. But as you can see here, like you can construct like a training loop, and you also have callbacks, but it's much more fine grained than what you get with PyTorch Lightning. Like you can create your own training loop, and but the important thing is that you give it like a state, which is in this case, actually, exactly the train state we're using and your data set, and
And
and then you get like the training loop, but with checkpointing and a progress bar, and I mean, I want to add better documentation, but I think this could be more suited for the JAX ecosystem than Elegy.
people are asking if this is like Torch Ignite for Jax.
PyTorch Ignite could be. I know the one of the creators of PyTorch Ignite works in Quansite. It could be something along those lines. It's a little bit more functional, which for the JAX case makes even more sense. Like if you're doing complicated stuff like a Keras like API, you get stuck. Even a PyTorch Lightning API, you might get stuck because in JAX, you sometimes want to do like more crazy stuff. So I found that this API is much better because it you just create whatever function, which in this case looks like this. Like you have a state and a batch, and then you return some logs and the state. So exactly what we did in this tutorial, and then that API fits much better because it's functional. And in the future, I'm imagining you can create more high level abstractions in top of this.
Hmm.
Anyway, that was kind of a yeah,
But yeah,
like a plug.
thankfully, I just wanted to point out that yeah, thankfully, I think Cyclo born of the necessity of replace CLU, the JAX CLU, the common loops utilities,
Not replace.
and
You can use CLU. Actually, it's kind of a
I mean Christian told me about Cyclo, but I previously I worked with the CLU tools, but it's a I don't know if it's still maintained repo because it hasn't been, and they
sort.
say that it's not going to update eventually that repo. So it's cool that now you have this kind of tooling. So I really think that if you are interested, please give a stars to the to the
Oh
Christianist
well,
development and
yeah. I
and
don't know if you're gonna use it. Like just like huge warning. This um is it's not really. Oh, it has 13 stars. Why? Okay, I've been using this for myself, but as David said, CLU. Yeah, actually, CLU. The idea is that everything in CLU works with Ciclo, but this is a much more low level but better suited API, in my opinion. Uh, there are other stuff like
but honestly, before you figure out, I think that we should left this kind of stream
yeah,
like the
yeah, yeah, yeah.
signal for the next because otherwise I know that we're going to get up
Sure,
when we
sure.
finish
Let's
this
end here, and hopefully very few people reach the end of the stream. But
shit.
yeah, we went over time. Yeah,
We did a lot.
David.
Actually, that was cool. That was really, 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 really cool that we did a lot. So, I don't know. Maybe next week.
Yeah, this is great. Let's continue our Jack's journey and see where it takes us.
Yeah.
Okay.
So, all right. Thank you,
Bye,
Mr.
Mr. David.
Christian.
Bye, everyone.